Welcome. Today, we're exploring the future of SIP through the lens of automation, digitalization, and verification. I'm Dr. S.K. Singh, and together, we'll dive into how these forces are reshaping the way we work, making processes smarter, faster, and more reliable. Let's get started. Let's start by looking at sterilization in place, or SIP, and how it's grown beyond just steam sterilization. Traditionally, SIP programs depend on periodic validation, manual record reviews, reactive maintenance, and analyzing past trends. But that's changing. The future points to smart SIP systems, ones that can monitor themselves, diagnose issues, optimize performance predictively, verify continuously, and keep compliance in real time. It's a shift from reactive to proactive, making contamination control smarter and more reliable. Let's look at how the industry is moving forward with SIP technology. We start with validation, then move to verification, and now we're aiming for continuous assurance. The journey begins with manual monitoring and paper records in SIP 1. Then automation takes over in SIP 2, using PLC-controlled cycles. SIP 3 brings digital records and audit trails. Next, SIP 4 integrates AI and the Internet of Things. Finally, SIP 5 envisions fully autonomous, self-optimizing systems. It's a clear evolution towards smarter, more reliable processes. Let's talk about continuous verification. It's an ongoing process where we collect and analyze operational data to make sure SIP systems stay in control throughout their entire life cycle. Traditionally, this meant annual reviews and occasional requalification. But the future is all about real-time monitoring, tracking temperature, pressure, steam quality, hold time, and equipment performance continuously. The big benefit: we catch any process drift early, before it turns into a failure. It's proactive, not reactive. Let's walk through the smart SIP architecture, the backbone of the future SIP ecosystem. It starts with sterile equipment, equipped with smart sensors that constantly monitor conditions. These sensors feed data into PLC and SCADA systems, which then connect to an industrial IoT platform. From there, an AI analytics engine processes the information, powering a continuous verification dashboard. Finally, automated compliance reporting wraps it all up. The result: real-time visibility into sterility assurance, a game changer for safety and efficiency. Let's talk about how artificial intelligence plays a role in the sterilization improvement process. AI helps us stay ahead by spotting trends before anything goes wrong. That's predictive performance monitoring. It also digs deep to find the root causes of issues, so we're not just treating symptoms. Then, AI optimizes the entire cycle, making sterilization more efficient. It even predicts risks to sterility before they become problems. For example, AI can detect a slow drop in steam penetration caused by condensate buildup, prompting corrective action before a validation failure happens. Let's talk about the Industrial Internet of Things, or IIoT, and how smart sensor technologies are transforming the way we monitor key process variables. We're tracking temperature, pressure, flow rate, condensate removal, steam quality, and valve performance, all in real time. This continuous data collection means we can monitor systems remotely, spot deviations faster, and gain deeper insights into how everything works together. Looking ahead, imagine every SIP system fully connected within a digital manufacturing ecosystem. That's the future we're building toward. Let's talk about digital twins for SIP systems. A digital twin is basically a virtual copy of a real, physical system. In this case, a sterilize-in-place setup. We use these twins to simulate sterilization cycles, analyze steam distribution, predict failures, and optimize design. For example, a digital twin can spot a cold spot in a transfer line before any changes are made to the equipment. This means fewer validation failures and quicker improvements in the process. It's like having a crystal ball for system performance. Let's talk about predictive maintenance in SIP operations. Traditionally, maintenance happens reactively. We fix things after they break. But smart maintenance flips that on its head. Here, AI steps in, analyzing pump performance, valve cycles, sensor drift, and steam trap efficiency. For example, the system can predict a steam trap failure 45 days before it affects operations. That means maintenance gets done proactively, cutting downtime and lowering the risk to sterility. It's a smarter, safer way to keep things running smoothly. Continuous process verification, or CPV, is a regulatory concept that shifts us from one-time validation to ongoing process monitoring. Instead of checking once and moving on, we keep a close eye on key parameters like temperature distribution, sterilization hold time, steam quality, alarm frequency, and biological indicator trends. This continuous approach gives us steady assurance, deeper understanding of the process, better compliance, and stronger risk management, all crucial for maintaining quality over time. Let's talk about data integrity in future SIP systems. As digital compliance grows, we're seeing key requirements take center stage: electronic records, electronic signatures, audit trails, secure cloud storage, and real-time review. These aren't just best practices. They're mandated by regulators like the US FDA and the European Commission. Looking ahead, the future state involves automated review by exception and AA-supported compliance monitoring, making the process smarter and more efficient than ever before. Looking ahead, regulatory expectations are evolving fast. Inspectors will focus more on areas like data integrity and continuous monitoring, making sure information is accurate and systems run smoothly in real time. AI validation and cybersecurity controls will also be under the microscope, along with how automated decisions are made. Lifecycle process verification and digital risk management round out the picture. Overall, regulators want manufacturers to use advanced technologies to boost contamination control and ensure processes are rock solid. As we wrap up, let's look at the key factors that will drive future success in sterility assurance platforms. Smart automation, industrial IoT connectivity, artificial intelligence, digital twins, and predictive maintenance all play a role. Continuous process verification, data integrity compliance, and lifecycle-based validation complete the picture. Together, these elements will transform SIP from a periodic check into an intelligent, self-monitoring system. Embracing these advances means better control, higher compliance, and ultimately, safer medicines for patients everywhere. When we look at key regulatory references, several major players come into focus. The European Commission and the United States Food and Drug Administration set important standards. Then there's the International Council for Harmonization, which plays a crucial role globally. The big trend we're seeing is a shift away from just periodic checks. Instead, the focus is moving toward continuous process verification throughout the entire product lifecycle. This approach helps ensure quality and compliance at every step. That brings us to the end. For any further support or questions, please don't hesitate to reach out. Thank you for your time and attention. It's been a pleasure sharing this with you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.